Good day all. Today we'll be looking at project profiling. The question says find the expression for abandonment time and cumulative production when decline is linear, hyperbolic, harmonic. Okay, now before we start solving, let's lay some basic foundation. A company that produces a product will normally undergo 3 stages or phases as they produce their goods. Now, this graph I'm drawing is a graph of rate of production to time. Rate of production Q versus time T. Now, a company that produces a product will undergo 3 stages. The first one is what we call the build-up stage, where their rate of production is increasing with time. So, as time goes by, they are trying to meet up to the customer's demand. Then to get to a point where they can't exceed a particular rate of production because they have gotten to their customers' demand. At that point, we see that the company is now at the plateau stage. So everything is now stable. They have enough equipment to produce enough products. Then finally, they will then undergo what we call the decline stage. Now, this decline stage is what our question is asking us now. The decline stage is where our focus is. So as you can see from the diagram, at this stage, their rate of production is decreasing with time. It is now decreasing. It gets to a point where there is the company no longer produces anything. At that point, we call that time where the company stopped producing anything abandonment time. Abandonment time is noted as TAB. TAB. Okay. Now, our focus, like I said, is this region. This region for decline. Now, our decline can be of 4 types. It can be linear, which is just a straight declining line. It can be exponential, it can decline exponentially. It can also decline hyperbolically. And finally, harmonically. So these are the 4 types of decline that we have. Now, we might not be able to tell their differences from the diagram, but a better way to say the differences between each of them is their expression. Now, the expression for linear is given to us as Q equal to QI, where QI is the initial rate of production. So from our graph, it represents the beginning tip or the beginning point of our graph. This is what our QI is, this beginning point. So our Q for linear is Q, our expression for rate of production at any time we want to look for, is given to us as Q is equal to our initial rate of production QI times 1 minus alpha T. Alpha is what we call instantaneous decline rates. Instantaneous decline rates. For exponential, our Q is given to us as QI, which is our initial rate of production, times exponential of minus alpha T. Then for our hyperbolic, we have that Q is equal to QI times 1 plus alpha T raised to power minus 2. Then finally for our harmonic, we have that Q is equal to QI times 1 plus alpha T raised to power minus 1. So this expression is what will differentiate each of them. So our question that is asking us to look for what? Abandonment time and what? Cumulative production. So this is our focus in today's solving. So let's start solving. Now for us to get the abandonment time of each of these steps, we are going to be making t in each of them. Set of formula. Okay, so for linear, we're trying to get the abandonment time. We say abandonment time is making t sort of formula. So with linear, we have that what cure is equal to cure I times 1 minus alpha t. Dividing both sides by cure I, we have that cure over cure I is equal to 1 minus alpha t. Okay, now let us rearrange them. This coming over here, why this coming over here, we will have 1 minus alpha t equal to, okay, so from here, let's take the 1 over to this side, and we have that minus alpha t is equal to cure over cure I minus 1. Let's continue from here. From here, we then have that t is equal to 1 over minus alpha times cure over qi minus 1. So we divided both sides by what? Minus alpha. So that is it here. Okay. Now, we won't just leave our answer like this. Since they were specific and they asked us to look for abandonment time, we can change, we change this parameter and this parameter. So we'll have our final answer to be CAB is equal to 1 over minus alpha times cure AB, which is our production rate at abandonment time, and cure I over cure I minus 1. So this is our abandonment time for linear. Now, they also told us to look for the cumulative production. The cumulative production of linear is simply the integral of the linear expression. So we're going to be finding the integral of what? This. So we are done with our friend abandonment time. For cumulative production, which is represented as the big cure subscript t of linear, the general formula is you finding the integral from 0 to t of q dt. Now for linear, our q is qi times 1 minus alpha t dt. 1 minus alpha t dt. That is the expression. This expression here is equal to this. So we substituted this value with this, and hence what we have here. Okay, so let's start integrating. This is a constant, we can take it out. Then we have that cure going out, cure I going out, the integral of 0 t 1 minus alpha t dt. Now we can separate it since there's a minus sign here. When we do that, we have that cure I multiplying everything, our integral sign of 1 dt minus integral sign alpha t dt, close brackets. Now the reason we separated, like I said earlier, is because of our minus sign. Okay, now from here we will then integrate 1. We have cure I. Integrating 1, we're going to be having integral of a number is definitely going to give you that number times t. That number times t. So in our case, 1 times t is what? T. So we write t down, not neglecting our boundary, which is these two values here. T0 minus the integral of alpha t. The way or formula for finding integral of any value. Let's say that ax raised to power n, and you are asked to integrate this. Your answer is going to be ax n plus 1 all over n plus 1. So this is the same thing we're going to be using in this case. In our case, our alpha is our a, our x is our t, our n in this case is 1. That's the power of our t here. So using that the same concept, 1, which is the power of our t, plus 1 is going to be giving us 2. So we have that our answer to be alpha t raised to power 2 over what? 2. Putting our limit t0, closed brackets. Okay, so from here we can now solve our boundaries. How you solve for this? Let's say you are given t boundary, and here is, let's say, 2, and here is 1. This is just going to give you 2 minus 1. So what is actually happening here is we are substituting t for 2 and subtracting t by 1. So if we have something like a t in boundary again, 2 and 1, this is going to give us a 2a minus a. So wherever you see your t, replace it with 2. That's this value. Wherever you then minus, wherever you see your t, replace it with 1. That's this value. Okay, let's try one more example. If you say a t divided by 2, the boundary 1 and what? 2. This is going to give you a 2a over what? 2 minus a over 2. So it's something just applying here. You substitute for your 2, and you got 2a minus, we substitute for 1, you get this. So that's just the idea for boundary. When we do that, we have that cure I in brackets is going to be giving us c minus 0 for this one, our t minus our 0, minus this one, alpha t square over 2 minus alpha 0 squared over what? 2. Definitely here is what? 0. So we are going to be having that our answer is cure I t minus 0 is t minus minus sign. Here is definitely 0. So this value minus 0 will still give, and we are still left with what? Alpha t square over what? 2. Okay, now this is our what? Cumulative production for linear. Now we can choose to stop here, or we solve further to eliminate the fraction in this bracket. We can have that qi. Now we're going to be finding LCM of this value, taking our common LCM to be 2. 2 divided by 1 is 2. 2 times t is 2t minus 2 divided by 2, 1. 1 times the value of the numerator, having alpha t square. Okay, now t is here, t is here. So we can then have our answer to be qi, the common t going out, over 2 times 2 minus alpha t. Okay, now for hyperbolic, which we're going to be looking for, is abandonment time. So we have this expression to be qi is equal to qi times 1 minus alpha t, 1 plus alpha t raised to power minus 2. So we are going to be making t sort of formula. Making t sort of formula, we are going to be dividing both sides by qi, which will give us qi over qi is equal to 1 plus alpha t raised to power minus 2. Okay, now for us to go further, we have to get rid of this bracket and this minus 2. First of all, let's get rid of the minus. This is indices. We can either simply just swap these two values, which is q and qi. Q goes down, qi comes up. So we'll be having qi over q. Or just follow the normal way. This is being indices, and in indices, this is how we represent it. Q over qi is equal to, now this is how we represent this in indices, 1 over 1 plus alpha t raised to power 2 this time around. The minus is just simply you saying that it is what? 1 over the inverse of whatever you have there. Okay, now for us to bring this value, which is denominator, up, to also have to affect this value, which is our q over qi. So when we do that, we have that what? Qi over q is equal to 1 plus alpha t square. Let's get rid of the 2. We're going to get rid of it by what? Finding the square root of both sides. When we do that, we have that the square root of qi over q is equal to 1 plus alpha t. Okay, now let's take our 1 the other side. So we'll be having that alpha t is now equal to square root of qi over q minus 1. Then finally, our t is now 1 over alpha times the square root of qi over q. This is multiplying everything in the brackets. minus 1. So if you are dividing both sides by alpha, it is going to affect both this value and this value. So hence this answer. So like we said earlier, we don't leave our answer like this. Since they were specific and they told us to find abandonment time, we will then end it by saying this, that CAB is equal to 1 over alpha times QI over QAB minus 1. Our square root is just ending here. It's not affecting the 1. So be aware of that. Okay. So this is the value for our abandonment time for hyperbolic. So since we are done with finding its abandonment time, let us now look for its cumulative production. Now, its cumulative production is given to us as what? The integral from 0 to t of what? Q dt. We'll be asking this Q and the one with, and the reason I'm putting the bracket t is for me to just tell you that Q is a function of what? T. If you put it or you don't put it, it doesn't really matter. So they are the same thing. So this is our formula for cumulative production. Now let's start solving. Since we are dealing with hyperbolic, in this case, our expression is not going to be what? Q I times 1 plus alpha t raised to power what? 2 minus 2. Okay, dt. Okay, now q is a constant, qi is a constant. We can take that outside and we have qi is now affecting everything. 0 t 1 plus alpha t minus 2 dt. Okay, now we assume that 1 plus alpha t, let it be u. We want to make our work a bit simple and easy. Let 1 plus alpha t be what? U. Okay, now we also need to find one more thing, which is du dt, which is just simply just saying if we differentiate this, what do we have? 1 is a constant, so it is going to give us 0, but this is having a function of t, so this is just going to be what? Alpha. Now we won't just leave our answer like this, we will just leave it in form of du is equal to, so we're going to be multiplying both sides by dt, so we have it in this pattern. Du is equal to alpha dt, or you can say you cross multiply, anyhow you choose to put it. Now knowing this, you will get back to our solving, so we can then say that what? Q I times 0 to t is now going to be what? U. So put our values here with what? U raised to power minus t, and our dt, we are supposed to do this in as an expression of dt du and not the other way around. So actually this is meant to be written in this form. Dividing both sides by alpha, we then have that what? dt is equal to what? Du over u over alpha over alpha. Okay, so we just divided both sides by what? Alpha, to get that dt is equal to du over what? Alpha. So this is what we're doing. We want to change this our dt to this, so we're not going to be having what? Du over alpha. Now alpha is a constant, we cannot take it out, and we are having q I over alpha, the integral from 0 to t. From 0 to t, u minus 2 du, right? Okay. So now we can now integrate using our normal method. Since we are having our value to be raised to power what? Raised to power minus 2. We are simply just going to add it 1. So we'll be having our answer to be qi over alpha u minus 1. Remember, all over what? Minus 1. C 0. Okay. Now from here, going back to this. So we then have that qi over alpha is now going to be 1 plus alpha t minus 1 over minus 1 0 t. Our u, remember we stated it, this statement. So we just went back, and this is what we are having now. Okay, now implementing our boundaries, we will then have qi over alpha. It's now going to be, well, for our first one, it's now going to be 1 plus alpha t. Okay, minus 1 minus 1 plus alpha times 0 over minus 1. Okay, now this we have, from here we have qi over alpha. Our minus, we can choose to take it up, so we can have this not in fraction form anymore, and we have minus 1 plus alpha t minus 1 minus, the same thing will also happen here. Our minus will go up, but it will not affect this, our minus here. We keep changing here towards plus. Okay, so minus times minus is always giving us this plus. Now alpha times 0 is 0. 1 plus 0 is 1. So we are left with what? 1 raised to power what? Minus 1. Okay, from here we can then write this to be this qi over alpha. Now the one with the plus, let's bring it front, and this one will go back. We'll be having 1 raised to power anything is going to give us what? 1. So that is minus 1 or minus 20 or 100 or this thing is definitely going to give us what? 1. So we're left with what? 1 minus, but our minus sign will affect this other one, and we are going to be having 1 over, remember our minus is from here. Okay, 1 over 1 plus alpha c. Okay, now we have gotten our what? Cumulative production. We can actually choose to stop here, but this will be good if c was given to us. But in a case where what was given to us was rate of production at this time t, we will have to then find a way to get the cumulative production where t is not given but q was given. So for that reason, let us still solve further and express this in terms of q and not t. Okay, if we can recall from here, this value, this is what we're interested now, or using now. This is what we're using now. So 1 plus alpha t is what? The square root of qi over what? Q. So for that reason, you can then write this to be what? Qi over alpha 1 minus 1 over square root of qi over q. We can use this formula or this formula, whichever one that pleases us. They are all what? Correct. Okay, so let's do for harmonic. We are solving for what? Abandonment time of what? Harmonic. Okay, now the expression for harmonic is that what? Q is equal to qi times 1 plus alpha c raised to power minus 1. Okay, dividing both sides by qi, we have that q over qi is equal to 1 plus alpha c raised to power what? Minus 1. Getting rid of our minus here, we then have that qi. We are inverting this side of the equation over q. This is equal to 1 plus alpha t raised to power what? 1, but we input it. So if that is so, we can also get rid of our brackets. Okay, so from here we can take our 1 the other side, and we're left with alpha t is equal to qi over q minus 1, right? Now, dividing both sides by alpha, we then have that our t is equal to 1 over alpha, multiplying everything, which is qi over q minus what? 1. Now we can then rewrite our values. We have gotten our expression for t. Writing our values, we then have that abandonment time is equal to 1 over instantaneous decline rate times initial production rate over production rate at abandonment time minus 1. So this is our expression for what? The abandonment time for harmonic decline. Now let's go over to cumulative production. For cumulative production, we have that Q, capital QT, representing our cumulative production, is equal to the integral from 0 to t of Q dt. Now, since we know the expression for our Q, we can write this to be integral of 0 to t qi times 1 plus alpha t minus 1 dt. Okay, now our q is a constant, so we can take it outside. So we have that qi, the integral from 0 to t of 1 plus alpha t minus 1 dt. Now we're also going to be assuming some things. Here we're going to be also assuming that u is equal to what? 1 plus alpha t. Okay, now when you differentiate this, which is your du over dt, you have that what? The answer to be what? Alpha. When you differentiate this, if you differentiate 1, you have, if you differentiate 1, you have 0. If you differentiate alpha t, you have alpha. You have what? Alpha. Okay, Now we want to express this in terms of dt. So if we kind of cross multiply or interchange this value, we can then have that our dt is simply du over alpha. Okay. So with that being said, let's continue. So substituting, we're going to be having that qi integral from 0 to t of u, replacing this value with what? U, like we did here. Okay. Raised by what? Minus 1 du, also replacing dt with this value, du over what? Alpha. Okay. Our alpha is a constant, we can take it out, and we have that qi over alpha from 0 to t u raised by minus 1 du. Okay. Now from here we have to now integrate our values in we have to integrate this value in the brackets. Now there's a problem. If we are to continue, or if we are to use our normal method of solving integral, which is our ax n plus 1 over n plus 1. If we are to use this formula, we will find out that when you add 1 to your minus 1, you will end up having what? 0, which we don't want. So the truth is that in integral, whenever you see anything raised to power what? Minus 1, and they say you integrate it, it is simply what? The natural log of what? That value. So our answer will then be qi over alpha is now multiplying the natural log of u, of what? U, from t to what? 0. So before we can start implementing our boundary, we have to substitute back to these values that we had here. So when we do that, we have that qi over alpha times the natural log of 1 plus alpha t, 1 plus alpha t, bracket close, from what? T to 0. So from here, we can now implement our boundaries. We have that what? qi over alpha is now going to be multiplying the natural log of 1 plus alpha t minus the natural log of 1 plus of alpha times 0. Close brackets. Right? So from here, we have qi over alpha times the natural log of 1 plus alpha t. Now, alpha times 0 is what? 0. Then 0 plus 1 is 1. Okay, so we have minus what? Natural log of what? 1. Then we close the brackets. We have that the natural log of our 1 is what? 0. So we have that what? qi over alpha times the natural log of 1 plus what? Alpha t. Close bracket. So this is our expression for what? Cumulative production. If we are given the time and not Q. But in cases when we are given Q, I have to express this cumulative production in terms of Q and not C. So for that reason, let us just solve further. So this value, we had it before when we are solving for abandonment time. We had that what? That 1 plus alpha t is equal to what? Q I over what? Q. We then have that what? Our final answer is what? Q I over alpha times the natural log of what? Q I over Q. So in case if Q was given to you and not C, this is also what? The expression. So that's all for this video. Please subscribe, like, and share. And see you guys in the next video. Goodbye.